Namaste. Now we are going to see theory of computation. Under that, we'll see models of computation. So, the computation. In computer, whatever we do, it is a processing. The processing needs CPU, and the CPU, for performing the processing, it needs memory. Next, what kind of memory it needs? So there are different types of memory: temporary memory, input memory, output memory, and program memory. Now we are seeing different types of or models of automation. This automation or automata is classified based on this CPU and programming memory. Before that, we'll see what will happen if I give any inputs. Let me give the process or a function as this is what I have to compute, f of x equal to x cube. How I can compute this is, in the program memory it will do x into x, then it will compute x square into x. This is how it will work. This is the program. But I have to give the input. What will be the x value? So that input will be taken by the input memory. Next, what the temporary memory will do is that it will calculate the x into x first, and that value will be stored in a temporary variable, and along with that temporary variable, the other value 2 will be multiplied and the value 8 will be calculated. That is the value of f of x, and that value will be stored in output memory. This is how a computation will work. Now, as I already told, automata is basically CPU along with the program memory, and based on this it is classified into different types. Automata are distinguished by temporary memory. Here the different types are finite automata, push-down automata, and Turing machines, where finite automata will not have a temporary memory, push-down automata will not have the stack. Push-down automata will have the memory as a stack, and Turing machines will have random access memory. We can see the examples for that. If there is no temporary memory, then it is, one example is vending machine. Small computation power is needed. For this, even we can a lot of finite automata like dictionary creation, all those stuffs will come under this category, finite automata, where memory is not needed. And if you take push-down automata, the memory will be in the form of a stack. Example is compilers for any programming language. And Turing machine, random access memory will be the memory. Any algorithm like highest computing power, and there is like whatever real-time computers can do, the same thing Turing machine can also do. Next, if you see the power of the different types of automata, Turing machine is highly powerful when compared to push-down automata and finite automata, and push-down automata is powerful than the finite automata. This is the hierarchy. And we'll see the basic definitions needed for theory of computation. Language. A language, simply, it is a set of strings. What is a string then? A string is a sequence of letters, example cat, dog, house. Defined over, these are the sequence of letters which we have taken from the alphabet sigma. So sigma is a set which consists of the all letters A to Z. Next, alphabets and strings. We will use small alphabets. For example, sigma is the notation alphabet, and the strings it is consist of, usually that will consist of small letters, and the string it can be any combinations of or repeated combinations of the alphabets. Here we are giving the value U as AB, V as BBB, AAA, and W as ABBA. So these are strings. U is a string, V is a string, W is a string. Next, there are basic operations what we can perform on the strings. So for example, if I consider W as A, B, B, A and B as B, 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 A, 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 then if I perform concatenation, concatenation is nothing but joining two strings in the same order given in the question. So it is like when I say WV, then I have to concatenate the first string, that is value of W. Along with that, I have to join the value of V. So the value of W is ABBA, the value of V is BBB AAA. This is concatenation. The next operation is string reverse. String reverse is simple. Whatever string is given, in the reverse order we have to place. So if the string is from A1 to AN, then it will be from AN to A1. So an example is given. Next, finding the length of the string. Length of the string is how many symbols are there in the string. So how many symbols, that is the length of the string. So if here I have n letters or alphabets, so the value of the length of the string is n. These are the examples. Here in this we have 4 alphabets, so it is 4. Here we have 2, it is 2, and here we have 1, so the length of the string is 1. And when we perform concatenation, what will be the length of it? U is AAB, V is AB, AAB. The length of U is 3, length of V is 5. So the result will be 8. Next we have one important concept called as empty string. Empty string is lambda. So the length of the lambda will be 0. If I concatenate with any string, I will get the same string as the result. And I can concatenate either in the prefix or in the suffix. Next, it is a substring. Substring means when I have any string, I can take any letter in between, before, after or anywhere in the string, and I can say that as a substring. So in the first one I have taken AB as a substring, the second one I have taken ABBA as a substring, and in the third example I have taken B as a substring, and in the fourth example I have taken BBAB as substring. Here also we have the concept of prefix and suffix. In this, if I take the complete string as a suffix, then its prefix is lambda. If I take the first letter A, next the rest all will be the suffix. Next, if I take first 2 letters, the balance 3 letters will be the suffix, and if I take first 3 letters, balance 2 will be the suffix, and it will go on like this. Thank you. We'll see the rest in the next video.